back to renal. So we have osmolarity. It's the number of solutes, or in this case, we're going to focus on salt, over solution. In this case, it is, or number of particles per volume. In this case, this solution is made up of water. So we can play around with the concentration in the blood by changing the number of solutes or changing the amount of water available. In the kidney, or in the nephron, the basic functional unit of the kidney, 60 to 70% of everything that is filtered is reabsorbed in the proximal convoluted tubule. So the first part of the nephron, 60 to 70% of everything reabsorbed. That includes sodium, that includes your solutes, that includes water. Majority of stuff that's filtered is reabsorbed in the PCT. Now, how does it do this? Well, everything has a sodium-potassium pump. And the sodium-potassium pump uses ATP. The ATP drives, or is the energy source that drives this whole process. Now, what this pump allows is for other co-transporters or counter-transporters, which are secondary active transport, to either drag in salt, and along with salt, other things will follow. In this case, X will just be glucose. We're going to keep it simple. There's more than just glucose. You can drag in other solutes with it. But we're going to say glucose is dragged in with salt. Well, in addition to glucose, water follows salt. Anywhere that salt goes, water follows. One more time. Anywhere that salt goes, water follows. In the thin, so let's take a look at this. So that's the nephron. And this is the PCT. So the PCT, I told you, this is the blood returning to the body. So this would be a reabsorption of stuff, in this case glucose or salt, back to the body. I can kick out hydrogens, which is your acid, and I can reabsorb bicarb, which is your base. Now we're focusing on this, and we're just saying sodium-potassium pump drives this process here to allow salt to be taken back into the body, to allow the reabsorption of glucose and other particles, and to also drag water along with it so that water can be reabsorbed back into the body. What about the second portion? Well, there's a thin portion for the loop of Henle, thin descending, thin ascending, and thick ascending. Thick ascending is important because